How can you classify these substances? And guess what? Yes, that is by its taste. I can classify the substances depending upon its taste. This is the first thing which comes to our mind. Say the citrus food, that's lemon. It is sour in taste. Cake, it is very tempting and sweet in taste. Bitter gourd, it is bitter in taste. Chips, they are salty in taste. When even orange, it is sour in taste. So I can classify the substances depending upon its taste. Such as sour, bitter, sweet, and spicy. So in such way, when we are able to classify the substances depending upon its taste, this classification was been given earlier, that substances can be classified into different categories depending upon their taste. And based on that concept itself, the further classifications of the substances came as acids and bases. This is what we are going to learn in this lesson. On the screen, we are able to see right now all the citrus fruits, and we all are aware that these food substances are sour in nature. That is, they are sour tasting things. And this sour tasting things or the sour tasting foodstuffs are being classified as acids. So what are acids? Acids are nothing but the substances which has the nature of sourness in them. They have been termed as acids. This word acid is derived from the Latin word acidus or acere. Which are the words? Acidus or acere. The meaning of this word is sour in nature. So, the substances which are sour in nature or sour in taste, they have been classified as acids. So, remember one thing. All sour tasting substances, they show the same taste as well as they show the similar chemical properties. So what are acids? Up till now, whatever we have learned, that is the substances which are sour in nature are been termed as acid, and they show the similar chemical property, and it has been derived from the Latin word acidus or acid. There are few naturally occurring acidic substances. So let us explore these substances one by one. So which are these naturally occurring sour foodstuff? Vinegar. It's available in our kitchen. Even all the citrus fruits, you can even see these images over here. These are acidic. Gastric juices which are present in our body. Even sour milk, tomatoes, grapes, tamarind, an apple, and many more examples. These are the few examples which we have shortlisted. These all are what? These all are the naturally occurring foodstuffs. Purposefully, we have discussed about this foodstuffs right now because one question may arise in your mind saying that for us the concept of an acid is what? It is harmful. it is hazardous. No, it's not like that. This question we are going to answer further. But for the time being, remember that which are the naturally occurring sour foodstuffs? They are vinegar, citrus fruits, gastric juice, sour milk, tomatoes, grapes, tamarind, and apples. Now let's explore what are bases. See, bases are bitter in taste depending upon the classifications of substances based on its taste. Bases are the substances which are bitter in taste and they are slippery in nature. So these two words are most important to be kept in our mind. That is, bases are the substances which are bitter in taste. Example we can take of oil. And slippery, if we want to talk about, there's nothing but the day-to-day soaps which we utilize is the best example for it. It gets slipped very easily when we catch hold in our wet hands. So, bases are what? Bases are the substances which are bitter in taste and slippery in nature. Remember, we had just discussed few examples of naturally occurring foodstuffs, of acids, right? But remember, this classification of classifying the substances depending upon its taste, this was been utilized at this initial stage of the classifications of substances. And but but remember in this case that acids, some of the acids are very corrosive in nature if they are been handled in a pure form. So can I say that the lemon, a piece of a lemon which we are able to see right now here on the screen, is it harmful? No, it's not like that. See, it contains along with acid other traces of the components also along with it. So it's not hazardous, it's not harmful at all. These were the examples which we had seen. Are all these foodstuffs harmful? No, they are the most essential source of vitamin C, which is essentially required by our body. So can I say they are harmful? No, they are not harmful at all. This is what we have to make clear to our mind, that when I can say that acids are harmful or they can create any of an adverse effect on me. See, when I hold these substances which are acidic in nature in pure form, they can create harm to me. But the examples which we had seen right now of the naturally occurring foodstuff along with acids, they have some other substances. So they do not create any harm to us. Okay, so there are two more properties which we have to learn regarding acids, that acids in their pure form they are corrosive in nature. So whenever these are to be handled, they are to be handled in a very careful way. So the properties of acid which we are learning right now is that in the pure form, the acids are corrosive as well as they are irritant in nature. So this is a property of an acid in an pure form. This is what we had learned so far regarding acids. But in standard 9th this year, we are going to learn acids depending upon the radicals which it has. So let's review what the molecules of the compounds are made up of. So the molecules of the compounds are being made up of two parts. that is the positive radicals and the negative radicals. Okay. So let us take few examples to make this concept clear to us. Now, which are positive radicals, which are negative radicals? With the help of an example, let us see. See, in this table, the name of the compound along with its molecular formula we have written over here. The first one, if we'll talk about over here of HCl, the name of this compound HCl is hydrochloric acid. We can easily say now this is an example of an acid, but how to identify it? See, when we dissociate this HCl, it gets dispersed. When we dissolve this HCl in water, the ions or the radicals which are present in it, they get dispersed from each other. That means they get separated from each other. And when they get separated from each other, what do they form? They form ions or they form the radicals. So which are those radicals? Those are nothing but the positive radicals as well as the negative radicals. So the positive radicals are been termed as basic radicals and the negative radicals are been called as an acidic radicals. The positive ions are nothing but the basic ions and the negative ions are nothing but the acidic ions. So if we'll just see or talk about HCl hydrochloric acid, when it gets dissolved in water, individually this H and Cl gets dispersed. That means it gets separated from each other and the molecules of water helps them to form this positive and negative radicals. So in case of HCl, it forms H plus radical. So H plus radical is what? H plus radical is basic. And it forms the negative radical, that is the Cl minus. That means it is an acidic radical. So the compound which contains H plus radicals are being termed as acids. The compounds which contains H plus basic radicals are being termed as an what? Are being termed as an acids. That is the substances which on dissociation gives the positive radicals as the H plus radicals. It means the basic radicals, they are be termed as acids. And on the contrary, remember the substances when dissolved in water, say for example potassium hydroxide, that is the molecular formula for potassium hydroxide, it comes as KOH. When they are dissolved in water, they dissociate. What dissociates? Individually potassium and this hydroxide group, they get dispersed from each other. They get separated from each other. And the water molecule helps them to form two radicals. Which two radicals? The positive radicals and negative radicals. Positive radicals are called as an basic radicals and negative radicals have been called as an acidic radicals. So when it gets dispersed in the water medium, that is the solvent, it forms two radicals, that is K plus and OH minus. This substance which forms OH minus ions or OH minus radical, this OH minus has been also called as an hydroxyl group. When the substance When it dissociates and forms OH minus ion, that substance is nothing but a base. So, what we have learned right now, the substance containing OH minus ion acidic radicals are being termed as an base. And the substance containing H plus ions are being termed as an acids. So we have explored two examples right now. Let us understand the few other examples. HBr. The molecular formula of hydrobromine is HBr. When it gets dispersed, when dissolved in water, what does it forms? It forms the positive ion as well as the negative ion. That is the positive radical and the negative radical. The positive radical is of hydrogen and the negative radical is of bromine. So it comes as H plus and Br minus. So we had learned just now, that is the substance or the compound containing H plus radical is termed as an what? It has been termed as an acid. So HBr, that is hydrogen bromide, is what? It's an acid since it contains what? It contains H plus positive basic radicals. The next example of sodium hydrobromide. Sodium hydrobromide, the molecular formula for it is NaOH. When it is dissolved in water, the individual sodium and hydroxyl group, it gets dispersed from each other, and when they get dispersed with each other, what happens to them? They form ions or they form the radicals. Because of whom? Because of the water, because it's dissolved in water. So it gets dissociated, and when it gets dissociated, it forms two radicals. Obviously it will be one positive and the next one will be negative. So it forms Na plus and it forms OH minus radical. Okay, OH minus is an acidic radical, and we had learned the definition of an base just now. That is the substances which gives OH minus ions as an acidic radical, they have been termed as an base. But if the question arises that if there is a substance which doesn't consist of this H plus ion and this OH minus ion, then what we can call them? So let's see an example based on it. Say for example, if you have an compound named potassium chloride whose molecular formula is KCl. So when it dissociates, which are the radicals it forms? Obviously positive radicals and negative radicals it will form. That is the basic positive radical and the acidic negative radical. So it forms K plus and Cl minus. But in this case, we are not able to see the positive H plus basic radical, as well as we are not able to see the negative OH acidic radicals. So in this case, what we can say, a substance which does not contain H plus basic radicals nor even acidic negative radicals, they have been termed as in what? They have been termed as salts. So depending upon the radicals, we can classify the substances as acids, as bases, as well as salts. If the substance consists of H plus as an basic radical, then it will be termed as an acid. If the substance consists of OH minus as an acidic radical, then it will be termed as an base. And if the substance doesn't consist of the H plus basic radicals or even the OH minus acidic radicals, it will be termed as an salt. So in this way, we had just seen that how the compounds or the substances depending upon the radicals can be classified as acid, base and salt. Hope so you all have understood this.